Hello guys, in the name of Allah, welcome back from another video series of tutorials of GIS and RS application in softwares from my channel. Today we are going to start in this video a new version of the videos by the ending the tutorials of the Google Earth Explorer. Now I'm going to create a template tutorial of the Envi software. It's an image processing application or software. So in Envi or an image processing application that's used mostly all over the world. In this series of the videos, we are going to discuss about various applications and capabilities of this application theoretically and practically, step by step. And I wish to find the time and opportunity to complete these tutorials to be used by those who need to use this application. So let's see what's Envi or what's for this application. Envi is a remote sensing software or an image processing software that is designed and created to extract information from satellite imagery. This is not a GIS software or does not have enough capability to be used in GIS modeling. And it's mostly feasible or mostly appropriate for the processing of raster data like satellite image, not for vector analysis or vector modeling. And it has high capabilities in image processing, and it's very simple to use. You will get familiar with this very soon, and it's a user-friendly software. At the same time, it has strong tools for classification, for calculating the indices, for any other purposes. And image processing has strong tools, and these tools are can be easily accessed by the users. At the same time, it's very fast to run. You can run it quickly. The softwares that has heavy tools like ArcGIS and other applications need much more times to run. It takes several minutes, but Envi has strong tools at the same time. It runs very quickly. And if you follow this tutorial completely, what would you learn in this tutorial? First of all, we're going to take a look to the environment of the Envi and its features and capabilities and applications. After that, we will go directly on image processing. That you know, image processing has 3 mini steps: pre-processing, processing, and post-processing. So In pre-processing, you will be involved with radiometric corrections or radiometric calibrations, atmospheric corrections, and spatial and spectral subsets to specify uh, your necessary bounds and your proposed study area or location to be subsetted and mosaicing the images. All these will be discussed in the pre-processing of this tutorial. But in processing files, we'll calculate and show you and teach you how to calculate various indices in the environment of the Envi and apply classifications, both pixel-based and feature-based classifications. And you will learn how to extract the features from Envi environment. And also post-classification is the final step of your classification. Did you apply some filters to enhance your classification, or you assess your accuracy to get valuable information and to know about the efficiencies of your classification? And finally, you can export and create your map into other applications like ArcGIS or QGIS or Saga or any other applications that you are familiar with that application, or you have accessibility with that. So this is the environment of the Envi software. This the visual parts of this application just looks like other applications. In this section you see the menus, quite like other applications: file, edit, display, place mark, view, and help. So each of these contains some tools, and filing it is quite like other applications, but in display you see some specific tools here. Just is usable in these applications. Maybe such things will not be visible or available in other applications. And also in this part you see the toolbox, all the things or all the toolboxes that you need to use in your image processing is available here, and you can just can access just by typing. For example, if you want to apply atmospheric correction on your image, just you can type atmospheric correction. And you see various type of atmospheric correction here: Tor atmospheric correction, thermal atmospheric correction, quark atmospheric correction, flash atmospheric correction. And each of these will be discussed during the image processing. So, and these tools are related to your data, and you can check from here your data manager how many data or images are opened in your workspace or in your software at the same time, and you can check its value, and you can use the pointer or the rise up hand symbols to move on your image across your screen. And these are for setting your extent and zooming in and zooming out on your image. In this part, you see the ROI icons. So here, let's move to the real image processing. And whenever you want to open a satellite image, and you must go through the open as. When you click here, you have various type of data and images here, a long list, and you can look for each according to your image to open your image. For example, leader, Lancet, military, overview, all these are the names of the satellites or the type of the satellites, and each satellite has a specific data type or each data acquired by the satellites has a specific extension like TIF or any other extensions. So you need to open through this the data to be read by the application correctly. So when I'm going to open a Lancet image, I go through this Lancet, and from here Lancet GTIF with metadata. And here is various type of Lancet data. So when I click here, I will take into the destination and go through my destination. For example, from here, I'm going to open this. Look at this. Here you see a multi-spectral file. The file that all the metadata related to these images stored in this image. If I open this here, that you see, this is not only an image. This in that destination, you just see this file. It's a text file that stores all the information about all these bonds and images. And whenever you open this through the application, all the data will be available in your workspace into the Envi environment here. And now I click here, say open, and all the bonds of this image will be imported into the software. When I click my data manager, and I see here that this image divided into the 4 parts, and here we have one thermal infrared and an image related to the zeros, and the next image is panchromatic, and one is multi-spectral bonds. So, and all the data that you see here is available here too. You can see here, for example, bond 1, 2, 3, 4 up to bond 10, bond 11, and BQA. And each bond has a file that contains its information, its value. And here is a file. It's the file of multispectral that we use to open the image, and it stores all the metadata about this image. When I open this file, you will see in WordPad. Let's take a look into this. the group of the metadata and group of the info. So as you see here, and Lancet Sense ID, this is the ID of the sensor, and this is the ID of the product, exactly the unique identification of this image, that this image can be identified in USG's website. Whenever you try to find a specific image, every image or every satellite image that's presented or accessible for you into the USG's website is identified by unique ID. This is for this image. So in here you see a lot of information. The process, software in its version, the date of acquisition, the image was acquired. You see here date of acquired, for example, 2021, March 31, and the path of the image, the row of the image, and USG's website, and also the time of the acquisition. You can see here sends center time, so 6/13/27 according to Greenwich time. So, and many other information that most of the time we use some informations related to the our processing from this metadata. And you can see here the corners of the image, left corner, right corner, and the maximum for a month, the minimum for a month, the maximum radiance, the maximum reflectance, and all these can be available and accessed through here. So now if you move through the image on your screen, you must use this pen. So you can move any destination on the image and anywhere on the image. Just you can zoom out or zoom in according to your options or your purpose. In Data Manager, here are the number of the bonds. So constellar is the first bond, below the second bond, green, the third bond, red, the fourth bond, near infrared, shortwave infrared to panchromatic. And the resolution for this image is 30 meter by 30 meters. You can see here pixel size in X is 30 meter, pixel size in Y is 30 meters, or 30 in the units you see here. And this image is also projected, and you can check its coordinate system. Project system is USGS 1984 UTM zone 41, and the geographic coordinate system is USGS 1984 and it's run. And also you can check the extent of the image, right, left, and you can see here emitter. And you can see here the bonds and the information about the bond. So, for example, it is the causal aerial bond, and this is the wavelength. So, the radians offsets, and some other information that you need. So you can get the information about your image through its metadata from here. And if you want to check a specific location or the data or the values of a specific location, you can check through this. For example, cursor value. When you select this, here you have a path. This is open here, and you can locate your cursor value and move through the image. You can find the values, and here you have three values here. For example, 6,934 and 8,460, 11,045, 10,880. So this is the value that's in this location. So why this three? Because here you have an RGB option. It means now you see the composition or color composition of the three bonds here: bonds red, green, and blue. Whenever you change the bond composition and your visualization, and definitely your values in cursor value will change. It means that those three values are according to this your visualization. The first value is from red bond, and the next one is green, and the next one is red. So for a better visualization, you can create false colors here, and you can visualize the way that you like, or the way that visualization help you. For example, this is the color composition of this now. This composition. And if I want to change this false colors composition, so I can change just the bond. I'm going to visualize this image by the composition of the near infrared, red, and green. This is called the Rgb visualization. Now you see here the areas covered by vegetation highlighted by a red color here. If I change the RGB color from here, for example, I use bond blue instead of the red bond, and the red bond instead of the green bond, and near infrared as a blue. Now you can see like this. Everything changed. So when you load your image, the first thing is to be done is your subset. You must specify your image or the location that you want to apply image processing on that location. Why? Because if you check the size of this image, let me check it from its properties. This is approximately 2 GB, and it's too hard and takes a lot of time to process all this image. Then whenever we intend to process a satellite image, we don't need to process all the image. Maybe we need a small part of this area. Then we can subset our study area and only apply the image analysis or image processing on that location. It will take a short time and enable us to do this processing quickly or faster than this way. So we have many ways or many options to subset our study area. For example, during the applying radiometric calibration, you can apply your spatial subset too, or you can subset your study area. Radiometric calibration is radiometric correction. So it corrects the effects of the rotating Earth and some errors or some distortions affected by the morphology of the Earth, for example, aspect, slope, and altitude of the Earth, and some atmospheric effects. And it changed the values quietly to the value that reaches to the sensor or top of atmosphere. When I click here, the first option is to select my study area, my file. For example, here we have 4 files related to this image, and the first one is multi-spectral, consists of 7 bands, and the next one is 6 bands, the next one is panchromatic. And I'm going to say about the panchromatic band. Look at here. It was 30 meter by 30 meter, the resolution. And panchromatic is a band that has 15 meter resolution. When you need a higher resolution in your process, then you can apply an image fusion to make the resolution of your image better. So if I check now the metadata for this file, math input, and you can see here the pixel size for X is 15 meter and the pixel size for the Y is 15 meters, despite the multi-spectral bands. So if you want to check out this visually, for example, I zoom into this area, as you see here. And when I turn off this layer or uncheck this layer, you can see that the resolution for the RGB colors or most multispectral bands are coarser than panchromatic. Or panchromatic has a higher resolution than multispectral bands. So now I open the radiometric calibration, Then from here, you will decide to select which file be radiometrically corrected. Multi-spectral or radiometric zeros thermal measurement. And generally, we use the thermal atmospheric correction for thermal bonds, not but it must be radiometrically corrected at first. So now I select multi-spectral bonds. Here you have two options. Spectral subsets. You have here 7 bonds. For example, if you wanted to apply this correction, this calibration for only on the 2 or 3 of these bonds, you can select only your purpose bonds. And now I'm going to use all these bonds, just I select all of them. And spatial extent or a spatial subset. If you're sure about the study area, you can select your study area just by drawing here. Or if you are not sure about that, you have any vector data or any ROI, you can change your ROI first into a ROI or into a vector, then you can subset your study area. Or you can use any image. If you want to use any image, your image must be opened in your software and you can select, and you will be able to select from this list and you can subset by that. If you have a vector data, and you can select by selecting here, and you can subset your data by that vector, or you have an ROI, and or you must enter an extent for your subset, a coordinate system. North, west, south, and east. So for now, I'm going to subset my area just by drawing a rectangle here and select OK. In here we have, in the first option, we have radiance and reflect. And this will be selected according to your option and which one you want to. If you select the reflectance, your image will be calibrated, or to your DN or to your digital numbers will be converted into the reflectance. And if you select the radiance, it will be converted into the radian. When it is converted into the reflectance, it doesn't mean that it is atmospheric corrected. It means that the reflectance that reaches to the sensor from top of the atmosphere, still it has atmospheric effects and influences, and you need to correct the image atmosphere. If you are going to use in your atmospheric correction, flash atmospheric correction, you must apply flash setting. So whenever you apply flash setting, everything will be adjusted here automatically. So in here you have 3 options: double, float, unit, or integer. unsigned integer. It means you can't have minus values into your image if you select this one. But it will be great to select float here. Now, and here we have another option. You can see output interleave. You have three options here: BSQ, BIL, and BIP. So let's explain this a little bit more. This is the ways that bonds can be stored in your hard disk. And here you see BSQ or bond sequential or bond interleaved. And BIP is bond interleaved by pixel or pixel interleaved. Bond interleaved by the line or row. So let's see here. In here, if you store or select BSQ, your image is stored in your hard drive like this. The software, the computer, stores or saves the first bond, then the second bond, then the third bond. And your data will be stored in your computer based on your bonds. If you select BIL, bond interleaved by line, the first line of your first bond will be stored. Then the first bond of your second bond, the first line of your second bond will be stored. Then the third one, then the fourth one, and like this. It will be continued. The first line of first bond, the first line of second bond, the first line of third bond, the second line of first bond, second line of second bond, third line of second line of third bond, and third line of first bond, third line of second bond, third line of third bond. It will be stored like this, in this sequence or in this interleaved. And in BIP, it will be stored according to your pixels. For example, whenever you save a picture by BIP, here, select this option, then your image will be stored like this. The first pixel from first bond in the first line. Then the first pixel from second bond. Then the first pixel from your third bond. So this goes like this. And all this has its advantage and its disadvantage, its cons and its pros. So whenever you select this option, maybe it takes a long time whenever you want to select a location or do a process in your study area. For example, I'm going to extract the water body in this area. So the software would be forced to read all the pixels of the first bond and the second bond, and go to the third bond, the fourth bond. It takes a lot of time. So when it is saved like BIL with BIP, and the software can find the data on the on a single location. As you know, the software saves the data into the tracks and clusters on the hard disk. When you save in these two ways, maybe the location that we are going to process its image or this part of image, maybe it's located on the same cluster in the same track. But when we save like this, maybe the computer will be forced to process all or to look into many different tracks and clusters to retrieve or access this data. Anyway, it depends on your process, on your system quality, on your speed of computer, on your size of data. So you can decide according to these factors to which one must be selected. If you want, or if you possess, if you have a system or a computer with a great performance, and then you are not worried about saving the file formats of it, and you can select output interleave, any of this. Whenever your computer performance and the time of process is important for you, then you must be careful about saving your file as BSQ. So at the end, I'm going to select a location here. I'm going to create a folder by the name of preprocessing. And Radiometric Calibration. Whenever you name a folder or a file, be careful about the names you type. Because by passing the time, this naming of the files will be part of your personality. And whenever you are doing real projects, but you saved the files with different names, and whenever you want to retrieve your data or look back to your data, you can find it. So now I click OK. And here you can see that radiometric calibration is taking place and it's visible here. Now I zoom out in this image to check my image. Now we have only the location that we have selected to be subsetted. And here we have all the 7 bonds that we have selected and spectral subsets here. Now, when I change the RGB, that's it. So, most of the time, it's not usable for us to subset the data like this. So what should we do? Maybe we have the exact location for our study area, and our study location must be subsetted in very exactly. So in that time, I will subset my data by my study area map, for example, a district. When you type here vector to ROI, you have an option here. And you can go back to your folders and the location that you saved your ROI, for example, my study area. So it's not accessible here. Let me check it. Oh, I don't have any file in this location. So let me to export to create a shape file according to the study area. I'm going to select the Afghanistan level 3. Then I have to import one bond of that image to check to fit the exact location. For example, bond 6. I'm going to clear my selection. Then like this. Now this is this part of our image. Now I'm going to create a study area by this district. Part of district must be part of my study area location. Now I export the data. Let me select a study area. No. And now, whenever I select this and go through this study area, now I have here my shapefile, and I select SHP file. Then I select OK. And all the records of this vector data must be part of a single ROI. Then I select OK. Then I select my file. Here I have a multi-spectral image and radiometrically corrected image. Now I'm going to apply on this. So whenever I select this, you see all this area is covered by this red line. And whenever you want to subset your image by this study area, you have different ways. So you can use a spatial subset. Subset data by ROI, or you can use this when you are applying radiometric calibration on your image and you have different ways. Now I'm going to subset my data by this way. I use this. Now I select the multi-spectral data, I mean this image, then you can click OK. So from here you can select, this is your vector data that you imported into your computer, and this is your ROI. So in here, mask pixel. If you select mask pixel output of ROI, all the pixel outside this study area, I mean these locations, will be masked. Otherwise, you will have a value of 0 in the extent of your study area. Let's check. First, I will try it without masking. So now here I set this subset and OK. I wait the data must be subsetted. You see here that your data is subsetted by its extent, not by the exact location. And when you apply this ROI into this, you see here, just this image was subsetted by its extent. The south extent, the north extent, and the west and the east extent. What happens if I do this by applying mask? For example, this band, OK, and ROI. And here, when I say yes, what would be your masked value? If I select 0, you will see the value of the 0 around your subsetted image. For example, let's try this. OK. Now you see your study area subsetted quite like your ROI or your study area. You see this.